Hello, myself Udit Pandey and I'm going to teach the topic motion. So, whenever we say the word motion, we basically refer to the movement or the moving objects. We have heard that our earth revolves around the sun. So, technically our earth is also in motion. We have saw the birds flying in the sky, so they are in motion. We have saw cars driving on the road, they are in the motion. We are able to see all these objects moving, so we can say that they are in motion, but there are also several other things which are in motion but we are not able to see them. For example, the blood inside us, inside our veins, flows, so it is also in motion. And also the atoms and the molecules, the smallest quantities, they are also in motion. Now we have studied about the motion, basically what it is. So now let us come towards the distance and the displacement topic. So basically what is distance? For understanding the topic distance, we will take an example. Suppose take a boy Rohit, named Rohit, and he starts running in a circular ground from a point A and he completes one round. The radius of the ground was 10 meters. So we know the formula for the circumference of a circle or the perimeter of a circle is 2 pi r. So we will basically put the value in the formula and the circumference will come out to be 62.83 meter. So the total path covered, the Rohit covered 62.83 meter distance in one round. So if he same way, if he completes four rounds, he will complete 251.32 meter distance. So we concluded to the point that distance is the length of the total path covered and its SI unit is meter. So now what does the point displacement mean? So displacement is the shortest distance traveled between the initial and the final position. Please focus on this initial and the final position. It means that, for suppose, take the same example Rohit. He starts from the point A and he completes one round. So he started from the point A, so it is his initial position, and he comes back to the same point, so it is his final position too. So technically he covered no displacement. He covered the distance but the displacement was zero as the distance between the initial and the final position is zero. So we have studied about the distance and displacement. Now let us study about the vector and the scalar quantities. You would be saying that I am teaching the topics randomly, so I will bind all these topics together at the last and then you will get the complete gist, how these are interrelated and connected to each other, these all terms and topics. So what is this vector quantity basically is? Vector quantities have both magnitude and direction. Now you would be confused what is magnitude. You would be knowing direction, east, west, north, south. Basically, we know about the directions. But what is magnitude? Magnitude is the quantity. Suppose we take the example displacement. So displacement, as I've told earlier, that it is the shortest distance traveled between the initial and the final position. But I missed one point, that is it has direction also. So what do you mean by it has direction also? For suppose I take an example that I'm going from a point A to point B. I cover the distance. I don't know what is the direction. But if I talk about this, the term displacement in that, from if I travel from a point A to the point B, which is in north. So now I know the direction also, and I have a quantity that I traveled 20-meter distance. So that would be the magnitude and direction as I told. So these are the vector quantities. Now let us talk about the scalar quantities. What are those? Scalar quantities only have the magnitude, as I told, that distance. So distance traveled between the point A and B is 20 meters. So they only store the magnitude. So this is what vector and scalar quantities are. So let us study now the point, speed and velocity. So I've shown two examples, car moving along a simple line and car moving along a arrow with a direction. So now let us know what basically speed and velocity are. Speed is the time rate at which an object is moving along a path. It is a scalar quantity as it is only having a quantity, not the direction. As I told that to be vector quantity, a quantity must hold the direction as well. But the velocity is the rate and the direction of an object's movement. So definitely if it is having the direction along with the rate at which the object is moving, so it is a vector quantity. The SI unit for both speed and velocity is meter per second. The speed is distance over time. So the formula for it is d upon t, s equals to d upon t simply. And simply if we require t, so we will just interchange it, t equals to d upon s, and we will take out the formula for t and d as well. So now let us learn about what the formula of velocity is. Velocity is displacement over time. So simply its formula is delta s upon delta t. In let us let me tell you about one point, that all the vector quantities have a dash, a arrow above them to show that they are a vector quantity. So if we have studied about the speed, velocity, displacement, distance, now we should also learn about the topic acceleration. What does the term acceleration means? Acceleration is the change in velocity over the change in time. So what does this change in velocity means? So it means the final velocity, the difference between the final velocity and the initial velocity. So what does this final velocity and initial velocity mean? Suppose a car started, and when the car starts, it starts with the definitely from the rest position, so zero speed, and it moves to the speed of 40 kilometer per hour, so 0 to 40. So the initial velocity was 0 and the final velocity was 40. So this is how we take out the change in velocity. Now we have studied about all the basic terminologies which will made you easier to understand the complete chapter. So we have studied about the speed, time, velocity, displacement, distance, acceleration. Now let us come into technical definition of the term motion. So what does this motion mean? Motion in physics means the change with time of the position of or orientation of the body. So it is a bit complicated for you to understand, but I am making you sure that by the end of the complete chapter, you will be able to get all these things completely. So the motion is basically of two types, uniform and non-uniform.